Alright, in the previous lecture we have learned deletion of a node from Circular Doubly Linked List in 3 different cases. Now in this video we will look at how to delete entire Circular Doubly Linked List, and we will implement it in practice. We know from previous lectures that in case of single linked list, if we set head and tail references to null, the entire list gets deleted. But here in case of Circular Doubly Linked List, this is not the case. Because even if we set head and tail references to null, node 1 will not be deleted. Because there is a reference from the node 2 over here, and there is another reference from last node to node 1. So it will not be deleted. And similarly, node 2 cannot be deleted because there is a reference from node 1 to node 2, and there is a reference from node 3 to node 2. So what do we do in this case? So here, the first thing that we are going to do to set last node's reference to null. So by setting last node's next reference to null, we are deleting a reference from last node to first node. Then, as we did in case of double linked list, we will start loop through Circular Doubly Linked List and update the previous references of each node to null. So we will start from the first node over here. So if we set first node's previous reference to null, the reverse link between first node and the last node gets destroyed. Then we are continuing to the next node, which is second node. So here again we are setting the previous reference of this node to null. So by setting it to null, we are deleting a reverse link between node 2 and node 1. Then, after doing so, we are continuing to the next node. So when we reach the node 3, once again here we are setting the previous reference of node 3 to null. So by doing so, we are deleting reverse link between node 3 and node 2. Then, we are continuing to the next node, which is the last node in our case. So here again we are setting the previous reference of last node to null, and this destroys a link between node 4 and node 3. Now we have deleted the previous references of these nodes. Now we need to set head and tail references to null as well. So by setting head reference to null, we delete the reference from head to first node, and by setting tail reference to null, we are deleting a link between tail and last node. Now if we look at these nodes over here, we see that node 1 is not pointed by any given node. So this means that this is eligible for garbage collection. But here, node 2 is referenced by node 1, so we cannot delete node 2 right now. So the garbage collector comes and delete node 1. So after deleting node 1, we see that there is no reference to the node 2, so node 2 gets deleted as a next step. So after deleting node 2, we see that node 3 is not referenced by any given node, so node 3 gets deleted. Then finally, after deleting node 3, we see that the last node is not referenced by any given node. So this means that this is eligible for garbage collection. So the garbage collector comes and deletes this node from here. So with this, deleting of entire Circular Doubly Linked List completed. So let's switch to Visual Studio Code and create delete method for Circular Doubly Linked List in Python. Now here again, inside Circular Doubly Linked List class, we will create another method after the method that we created in our previous lecture, which is delete method. So here I will define a method which is called delete Circular Doubly Linked List. So by default it takes self parameter. So as always, as a first step, we will check head parameter. So if self.head is none, we will print out saying that there is not any element to delete. Otherwise, we are continuing to our algorithm. So here the first step is we are setting last node's next reference to none. So if we set self.hail.next to none, we are setting last node's next reference to none. So by doing so, we are deleting a link between last node and the first node. Then we will start to loop through Circular Doubly Linked List and set previous references of all nodes to null. So I will create temporary node over here and assign first node's value to it. Then inside while loop, we are setting temp node previous to none, and in each step we are setting temp node to temp node dot next. So here we are not providing any if condition to stop when we reach the last node, because as you see, before going to loop, we set the last node's next reference to none. So when we reach the last node, it will stop automatically. Then after setting all nodes previous reference to none, we need to set head and tail references to none also. And this will delete a link between head and first node. And then by setting tail to none, we are deleting a link between tail and the last node. So after these steps, the first node becomes eligible for garbage collection, then the garbage collector comes and deletes the first node, then after deleting first node, the second node becomes eligible for garbage collection, and it continues like this until we reach the last node. So after completing these steps, I will put print message here saying that the circular doubly linked list has been successfully deleted. So with this, we have completed our deleting of entire circular doubly linked list method. Now let's see how this is working in practice. So here again, we have created circular doubly linked list and inserted values in it. So then we are printing our circular doubly linked list. So here I will call our method .delete circular doubly linked list. Then after calling our method, I will once again print out the circular doubly linked list over here to see the difference very clearly. So let's run our code. So when we run our code, we see that initially our circular doubly linked list is like this. Then after calling delete method, it says that the circular doubly linked list has been deleted successfully. Then when we print out, we see that there is no element in it. So we have deleted all elements from the circular doubly linked list successfully. Now let's see what is the time and space complexity for this method over here. Once again, we'll start from the beginning. So at the beginning, we have if condition which takes head value, and we know that it's a one-time complexity. Then we are continuing to the else condition. In the else condition, the first line of code is we are setting tail's next reference to none. And we know that setting a reference to any given value takes a one-time complexity. So this part here will take a one-time complexity. Then we are creating temporary node, and creating a temporary node and assigning any value to it also takes a one-time complexity. So this part also will take a one-time complexity. Now next code over here, we are looping through the circular doubly linked list and setting previous reference to none. And here we are traversing all elements of circular doubly linked list. This means that it takes O(n) time complexity, because in this case we are visiting each and every element of circular doubly linked list and setting previous reference to null. And this takes O(n) time complexity. Now at the end, we are setting head and tail references to none and printing message over here. And this is also a one-time complexity. Now if we combine all these complexities over here, it's obvious that we are getting O(n) time complexity. Now the space complexity is O1 because here we just created a temporal node over here, and also we are deleting all elements from the circular doubly linked list. This means that an additional space is not required in the memory. So it will take O1 space complexity. So this is all for this lecture. Now in the next lecture, let's see all time and space complexities for circular doubly linked list operations that we performed till now. So by doing so, we will have a big picture of time and space complexity of circular doubly linked list. See you in the next lecture.